Suppose you have a bigger input image. After you do the convolution, the feature you get is this. But if we want to get a smaller feature, then we will do pooling. So pooling is like just trying to take the maximum value in this whole red region and then put it in the pooled feature map. So that the convolve feature may be so big, maybe I don't think, I think it's maybe 20 by 20. But after this pooling, the size will immediately shrink to like 2 by 2. So it's, again, it's trying to make your feature become smaller, which reduce your time and reduce the model complexity as well. But at the same time, it will still preserve the best feature. Because when we do pooling, usually what we do is to max pooling. So that means it will try to find the maximum value in this region and then put it in the pooled feature part. So if your feature map has a very high response in any places in here, in the final feature, you will have high response in here, no matter it's in which part of this sub-window. So by using the max pooling, you will keep the response of your convolution and at the same time reduce the complexity of your model. So which is helpful to avoid the problem about overfitting. Okay, so here is another flowchart talking about how do we do training of our deep learning model. So first, we prepare our data and do some pre-processing. And during the pre-processing time, you should know every ground truth of your data, right? So suppose it's a classification network, then you should know that which class your image belongs to, and you should prepare the one-hot encoding label for your data, and then you will transform your image into feature, or maybe not. It depends on your problem, and then fit your image into the deep learning model, and then you will get model output, which is the prediction. And then by comparing the difference between the one-hot encoding and the prediction, you will use a loss function to compute their difference. And then you will get the error. And then you will pass the error to the optimizer, and the optimizer will update the model parameter according to the backpropagation algorithm we talked about in the previous lecture. So after you do the backpropagation, then you update all the weights inside this deep learning model, and then you will keep throwing the new training data into this network, and this will go again and again until the loss function decrease to some threshold that you set, and then the training is on. So for the loss function, if you are doing classification, then usually we use cross entropy to compute the loss. So for the cross entropy, the equation is like this. So the predicted value, the output of your network may be like this. Suppose you are doing handwritten digit recognition. So there are 10 different classes, and the output of these 10 classes, suppose it is like this. And then this is yi. You put it in the log function. And you also have the one-hot encoding of this image. Suppose this one-hot encoding is like this. It has 1 in the class 7 here. And then this is the y prime. So at the end, it only look at the probability of this correct class and then compute this function. this is what cross-entropy does. Okay, so important factor in deep learning when you use that to do face recognition, it contains following three things. The first, how do you design the network architecture? So we need to design a complex architecture to enhance recognition rate. And the important thing is what is the backbone network that you use to do the classification. And sometimes we will use multiple network. So maybe you will train multiple network, one network for some specific kind of face. So like we said, in face recognition, we have 5 major problems, right? Do you remember what is the 5 major challenge for face recognition? We just talked about that last week, right? Don't remember? Let me show you the slides. This one. Right? Yeah, so what is this 5 challenge? So these are so-called PIEAO problems, right? Pose, illumination, extraction, aging, and occlusion. So these are 5 important challenges that cause your face recognition fail, because all of this will cause high intra-class variation and small inter-class variation. So talking about the network structure, maybe you will try to train one network to deal with maybe pose variation, the other to deal with illumination, the other to deal with aging, something like that. And then you can combine the final result together. So this is called ensemble. So it's called ensemble method, which is you can try to train multiple models to do things. Okay, and the second important thing is loss function. How do you design more complex loss function to match the recognition score, like verification score or identification score? Remember, we said that in face recognition, these are 2 important tasks we are dealing with, right? Whether you are doing face verification, which is 1-to-1, or you are doing face identification, which is 1-to-n. These 2 tasks are quite different. So depending on which task you are doing, you can design different loss function. And then your model will train to perform better in one of these tasks. And the third thing is distance matching. Which distance matching is more suitable for face feature? Like we know, when we want to compare or compute the distance of 2 features, usually these features are vectors, right? And in general, we will try to think maybe we can use L2, which is Euclidean distance, to compute their distance. But is that always the best thing we can do? Maybe not, right? Because Euclidean distance is just one kind of distance matching. Maybe we can try to think about other magic, which may be more helpful when we are doing face recognition. Okay, so next we will talk about this important factor one by one. So start from network architecture. So here we list a lot of network architecture that has been proposed in the past 6 years for face identification and verification work, and we will introduce them one by one. So first one is deep face, which is proposed by Facebook in CVPR 2014. So the point is, at that time, it was the best, as good as Face ID 1. And the con of this network is it requires large data set and not as good as Deep ID 2 and 3 and face map. And also they need to perform 3D alignment. So here is the flow chart about the deep face. So first, you get input face image, and then you need to detect the location of the face. And then you also need to detect the contour of the face, which is the facial landmark tracking we talk about. So if you can really detect the location of the eyes, brown and nose, mouth, and also the contour of the face, and then what you can do is you can apply a 3D model to fit this face image, and use this 3D model, you can try to normalize the face. So if the face is like this profile face is not normal, then use this 3D model, you will be able to rotate this face and then make it come to like frontal face. So it will perform normalization to transform this face into face like this. And also in Facebook model, they also trying to exploit the information across different color space. So like the input image is a RGB image. So they try to decompose the image into R channel, G and B. So one image will become three image in single channel. And then for every channel, they can build one neural network to perform classification. And the neural network is, the architecture is like this. So you can see that back then, the depth of the network is not really very long. So it's maybe just like 7 layer or 8. So it's not a very huge network compared to the later network we will describe. And they train with cross-entropy softmax loss, which is a classification loss. So basically they collect a very huge database. So you know, Facebook, what's the advantage of this company? Yes, that's right. It has tons of data, huge data, and more than you can imagine, especially people's image, right? Because people will take picture and upload to Facebook every day. So it has huge data about face. Yeah. And also those face image, I think large proportion of them is high quality image and with label, right? Because people tend to add labels of this face, like this is me or this is the other friend of me, right? Yeah. So these are a high quality image with good label. Yeah. So they have such huge face database and use that to train this model. And when talking about compute the distance of different face, they use a spatial mass equation. It's called chi-square distance to compare the distance. So given two features, the chi-square distance is computed using this. Okay, and they also do single model and ensemble model, like I talked about in previous slide. So single model is based on 3D aligned RGB input, single model. And for the face, deep face ensemble, they train on 3D aligned RGB image, gray label image, and also image gradient. So compute the gradient of the image. And 2D aligned RGB image. And if you have multiple model, but during the testing stage, you can input the image into these 3 models, and they will have a final recognition result, and you can combine them using voting. So the distance of ensemble model is combined using nonlinear or nonlinear SVM with sample sum of power CPD kernel. So here is the performance of deepfakes. So all of the methods listed in this section are existing method, traditional method. So you can see traditional method, the accuracy is up to like 95%. And all of these are deepfakes-based method. You can see that if you use ensemble model, which means you train multiple network to do things, then you can get as high as 97.35%. And for human, if you hire a human to do face recognition, then the human performance is 97.53%, which is similar to the base model of deepfakes.
Sure. What is the meaning of the previous slide's last sentence?
Which one?
The last sentence. This type of ensemble model is combined using nonlinear SVM.
Oh, so for this one, so ensemble model will produce output of like a vector, right? Because you have multiple model, and then you can use this vector as a new feature. Use that as a feature, and you train a nonlinear SVM to perform on that feature. Yeah. So it's trying to combine a lot of different machine learning and deep learning technique in this model to improve its accuracy. Yeah, so the important thing you want to remember is that it is the first time deep learning is proposed for face recognition. And for the first time, it already can beat human performance, you know. So in the machine learning world, one milestone that we care is whether our algorithm is as good as human. Because usually we think human can perform better than machine in the task about any recognition, like speech recognition, like image, object recognition, face recognition. We all think that in this kind of intelligent task, usually human is the gold standard. If our algorithm can outperform human, then this algorithm is very good and very powerful. So this is one of the take-home lesson about the deepfakes is that it is the first time that deep learning is used in face recognition, and it already can perform as good as human being. Yeah. So this is very surprising work, and after that, every research group in face recognition start to use deep learning. Yeah. So let's see the next one, which is deep ID 1. The 1 is added in the later, because later they have deep ID 2 and deep ID 3. Okay, so for this model, it is come from the Hong Kong Chinese University. Do you know that? It is a very famous university in Asia. Chinese is called 香港中文大学。OK， 所以在香港中文大学里面有一个很强的 CV 团队。好，那这个团队，你们有没有听过 ？Does any one of you have heard that there are very strong TV computer vision research group in Hong Kong Chinese University? Yes. No. Yes. Yeah, 香港中文大学. There are very strong team in there. It's led by Professor Tang Xiaohou. Okay, so Tang Xiaohou is graduated from MIT, and then he go back to Hong Kong, and he is also a researcher in Microsoft Research. Yeah, So his team has been devoted in face recognition research very long time ago. Yeah, and since the deep learning has come out, Professor Tang's team is one of the first few teams that do face recognition using deep learning. And also, Tang Xiao built a very famous company. Do you know what is that? In English is called SenseTime. 中文叫商汤科技. So if you have read some technology news, then you will know SenseTime is one of the biggest unicorn AI company in China. Yeah. So SenseTime has gathered the investment from China and from US, about $6 billion, and it's about to IPO. Yeah. So what I want to say is that the things you learn in machine learning class is very useful, you know. So if you can learn machine learning and deep learning, and you can master it to some degree, which is as good as other teams in the whole world, then it's very likely that you can make a startup company, and then this company will shine as Taiwan's biggest unicorn company, right? Yeah, so that's why I want to share this story with you. Yeah, so I guess you guys maybe don't read news very often, so you can go to read some news. Okay, you can Google 商汤就是商朝的这个商汤科技. This is a very famous company. This is one of the biggest company that get most fund in the whole China. So you know that in China they have a Skynet system in China, right? Which can monitor their protesters everywhere, right? And you know, SenseTime is one of the biggest technology source that help to build this system. Yeah. So I'm not saying that we should do something like this because I'm against China's censorship. Yeah, this is not good. But I'm saying that if you really learn a lot in our course, in machine learning course and deep learning, and you can master your skill to a very high level, then it is possible for every one of you to start your own company, and you can build a very influential company which has big impact to the whole world. So that's what I want to share with you. Okay, I think it's close to 2:50. Let's take a break, okay, and come back as soon.